Good morning. And this is a very, very important day. It was the last lecture that you get on the web portion of the curriculum only. So next week, you're going to build Wix, which is the best learning experience by far, okay? So it's a very exciting day next week. Well, tomorrow you have your sprint challenge, but everybody's going to pass it. So you're going into build Wix. All right. So web testing, I'm going to begin by showing you the challenge for today. It's going to be about testing a server. So just read the README. That's the instructions for this project. And make it open, make it happen. Look at this. This is the shortest thing that we ever gotten. Use test-driven development, create a RESTful API, set of endpoints, manage a resource of your choosing. So if you're into pets, pet manager. If you're into, I don't know, collecting Pokemons, a Pokemon API, right? So whatever it is that you want to do, you have that project that you want to build, start building the API here, write a few tests for it, right? We want to see at least 12 tests in there. Adding a database, a test database is optional, but highly recommended, okay? So see if you can figure that one out. You could use a memory array. That's okay, but I would say go full out. I mean, go all out and do your database. I'm thinking of even making this not optional anymore. Like you should have a database, right? That's it. When we say like download this and grab all dependencies, look at the dependencies. It's like, yeah, Express, Jest, and Super Test. That's it. Okay. Cool. Questions for the project for today? I'm sure you have a lot of questions. Is there much testing in the rubric for Build Week? I don't know. But here's what I would tell you though. When given the choice, unless forbidden specifically to do so, you should assume that it is your responsibility to document and to have tests, unit tests. Okay? You always want to have unit tests. Now, if your boss comes to you and says, I do not want you documenting and I do not want you running tests, then yeah, nothing you can do about that. So every time they ask you, how long is it going to take? You have to factor into account documenting and testing as part of the development process. Because that comes with the word quality. And you should never, ever, ever compromise on quality. Okay? When given the choice. So what you do is, you remember that saying of something like along the lines of better to ask forgiveness than permission? If later they come back to you and say, oh, I know why you took 2 days to do that, because you were writing tests. You're like, yeah, I thought I was supposed to. You play it dumb. They say, no, I don't want you writing tests anymore. Just write the code. And then now you got an order to not write tests. Then it's okay for you to go and write buggy code that is going to cost a lot more to maintain in the future. But it's not your fault, right? You can always go back to that day, make a note and say, you know, my boss told me on this day, at this time, on this second, he told me do not write tests. So from now on, I know my code may be buggy and there's no way I can prevent that. So quality more than speed. I'm going to give you from the management perspective. Remember, this is our last day together, so we're going to play very chill, like, yeah, you know, let's talk about the industry and stuff. So I'm going to give you the perspective from the management standpoint of view. Like I have, for me, every project has four pillars, right? We should probably have some code on screen or something. Let's take these notes and say, you know, a project has 4 pillars. Opinion. This is all opinion. Opinion. Let me do this. It's like opinion alert, right? Opinion. Those are quality. Okay. The other one is budget. Money. The Benjamins. The other one is time. And then the last one is scope. I personally, when I was managing, would approach every project with those 4 pillars in mind. Quality is the one, this is non-negotiable, okay? This is how you lose customers when you put out buggy code. This is, I'm talking about a software project, any software, build weeks, any project that you work on, because I ran a lot of projects in my time, right? So budget normally, not, and here's the thing, you see, budget and time, they're constrained. They're just, they're constrained. They have, let's say, you know, external constraints. And by this, I mean, the finance guy is gonna tell you, yep, yeah, this is all the money that we have, okay? In the case of time, the market itself, the company needs to survive in a market that is moving really, really fast. It doesn't matter what the industry is. If you're in cars, if you're in, you know, doing retail, whatever the industry, healthcare, the industry is moving so fast now that time is not like something that before you could say, I'm going to take 6 months to do this. No, it's more like if we're not out there in 3 months, we're dead. The market's not going to be there anymore for us. So this is also going to be an external constraint. In most cases, right? There may be exceptions, very far between, okay? So assume that this is the case, that the finance guy is not going to give you more money to hire more people, and then you're not going to have enough time to just take your time and stroll through the process. So those are external constraints. They're just there. You can't do anything about them. This one, this is your constraint. This is inner. This is you saying, I'm not going to put out some crap. I want good stuff out. So this is non-negotiable. So what's going to give? This one has to give. So whenever you're given the choice for you to select, what do I sacrifice out of those 4 things? And I know that you have heard this differently. You say like, you know, you have 3, pick 2 out of the 3, like quality, money, and time. I want to introduce to you on software projects, you do have scope. There's a possibility where you could say, okay, I'm going to identify my MVP, and I will concentrate on building that MVP first. And I'm going to leave the rest. And the MVP may be tricky to find. Sometimes we're working, most of the time we're working with data, right? Sometimes we have some data that is going to be there that we need for the software to work. And we could take a couple of days working on CRUD operations for that data. When you could have just written a simple seeding script. Let's say that you need to load data for, I don't know, let's say that you're the school, Lambda school, and we're building something to manage the students and the cohorts and the classes and all that. We could take a couple of days just writing endpoints and APIs so that we can manage the cohorts and the objectives and all the stuff that you see in training kit. But what if I just create a seed? Because I know what my courses are. I know what my cohort, the cohorts that I have right now are. Okay. What if you just write a seeding script that is going to take all of the courses, all of the tracks, all of the objectives for those, you know, like all of the lecture information, and I just load it on a seed script. I just save 2, 3, maybe a week of writing endpoints and writing CRUD operations and tests and all that. Because that data is not going to be changing maybe for another month. And now I can go and concentrate on the stuff that I really need to have done next week, right? So think really hard. Is there, and this is what I tell you, when doing auth, I mean, you could have, if you want to hide and you know, hide and show stuff based on people being logged in or not, simple Boolean will do on the front end just to get that out of the way. So you can concentrate on the important stuff, on the meaty stuff. Once you get that done, then you can go back and say, I'm going to take, and probably what I would do is I take my Jot project that is already working and it already has all of that, because you have a couple of examples. Take that and base my API on this. Okay, I have Jots now, and I'm sending Jots to the client. That's done. I could register, and I could log in a user, and I could send back a Jot, and I could verify the Jot when it comes. That done. Hey, front-end people, just grab this token that I'm sending you, save it somewhere in there. It could be in memory, local storage, and then send it back on every request, and I could validate whether you're logged in or not. And then concentrate on the rest. Do that like in the first hour, you're done. Okay? Don't spend time on that. If you have some master data that you need, unless the front end needs like to have forms to perform to handle that master data. And even if they think they do, maybe they don't, because they just need that data to show it on a drop down as part of their demo. So you could tell them, hey, can I concentrate on give you the stuff that's going to be important, and maybe that preloaded data I could just preload on the database for you, and you don't have to build that CRUD operations until you need to, because you only need it for that drop down. I could just seed it on my database and you'll have it there on the drop down. So I could just give you a get that you could get with some query string so that you could kind of do a partial search on that. And that's done. No need for them to build forms and all that, because only when they're doing the demo, that's not what's important. That's not sexy. A form for enter data, nah. Unless it's part of a process where you actually need to do it. And that is the 16 minutes of project management and kind of prioritizing. Questions? So yeah, I would say quality is maybe not higher than speed, but definitely higher than scope. Like, find the stuff that you really need to build right now and concentrate on building that MVP. The rest should probably work. Oh, look at this. It's escaping my dollar signs. Excellent. So I'm gonna do this Benjamins, because we talk in hundreds, right? We don't do Washingtons, we do Benjamins. Yeah, don't freak out on build weeks. And if you want to talk about this on your project, once you have your project, hey, hit me out. We could do it like a quick Zoom meeting and see if we can identify opportunities of what is the core functionality that you need to build for. I'm not saying you're not going to build it. I'm just saying you have to prioritize your time to make sure that the stuff that is going to be part of the core business, what makes the application special, adding CRUD data don't make application specials. The processes around that data and the things that you could do with that data, those are the things that make it special. This is where the business idea lives. So you want to target that business idea, and then anything else that you can pre-populate or kind of provide something really basic just to get it started, then you do that, right? So you could devote more time to the actual business logic, the stuff that you need to test really, really well, the stuff that cannot fail and that cannot be omitted, okay? So that's the opportunity that you're looking for. And again, sometimes you're not gonna have that choice. Sometimes you're gonna have a project manager and they're gonna give you a board, a Trello board or a Jira board, or GitHub board, where they're gonna tell you, this is the stuff that we're gonna do, and here's the first one that you have to work on. In those cases, it's easier for you. You don't have to think. What you do is do your magic. You take that card from that board and you say, I'm going to implement this feature the best way that I can, and as fast as I can, and as cheaply as I can. Okay? Always taking in fast and cheap is important, but the most important one is quality, with high quality. So if they don't tell you, don't write tests, you start by writing tests. And if they come back later and they tell you, as I said, oh, you took, 50% more time because you were writing tests, please don't write tests from now on. Now you know. But unless they tell you not to, assume that you should have tests. Because here's the thing. You might be the one working with that code base for years. Like in my prior company in the R before I came here, the software that we started writing in 2009 is still the one in production. So every little feature that comes out, every change of the ruling, this is healthcare, so there's a lot of, regulations and laws that change a lot as we discover more, things that we need to secure. So every time something like that comes in on a new feature, something that we want to add to that software, we have to work with that old piece of software that has hundreds of thousands of lines of code and different technologies. It's like a Frankenstein of a lot of technologies as we evolved over the years in 10 years, right? It's me, it's the developer that needs to work with that. So having those tests in there, helping you being able to refactor a feature, knowing that you didn't break anything else, makes your life so much less stressful, so much better. So you're writing the test for the quality of the software, but it's also for your own sanity. It's your own sanity. It's gonna save you so much time down the line and so much headaches. See, not pushing something Friday evening at the end of the day because you have a brand new feature, you worked on it all week, and then when you push, everything else breaks, and they calling you over the weekend, and you have to go into the office to work, and you're there at 2 o'clock in the morning, drinking, whatever it is that you need to drink, coffee or those energy drinks just to stay awake. No, you would rather be having fun, enjoying your family, right? Maybe going out with your kids and enjoying over the weekend and go to the park or something. You don't want to be at the office tracking down a bug just because someone made a decision before that says, yeah, just write code in there. It's a wild west. We'll figure it out later. No, write your tests. Make it a priority for yourself, for your sanity. All right, let's go write some code because now I'm any more questions. And if you ask me another thing, I'm gonna go another 10 minutes. So think about it really hard. All right. Okay, cool. So what is that we're gonna do today? You're gonna build an API, do whatever. We're gonna use this library, and this library can be used in different ways. As you can see right here. So you could take the examples from the website, and that's basically what we're gonna check. We want to check things because that's a question that you're gonna have. What am I gonna test on an API? Well, turns out that there are a lot of things that you can test. They're gonna require that you learn a little more about HTTP messages and headers and the different headers that you can have in there. So I would suggest you want to start really simple. I want you to think, what is a function? I want you to think, go from the pure function perspective. The easiest thing to test is something that you can just pass some arguments and you know exactly what's going to come out of it because it's predictable. It's a pure function, right? The response is always going to be a function of the arguments that you give it. Easy to test. I give it 2 and 2, I get 4 back all of the time, right? So if you go from that thinking, and remember that a React component is the same thing. It's just something that you give it some props, and it's going to give you some piece of UI. And with the same props, you always get the same UI, right? Unless it's an impure component that uses something else. So the easiest components by far are the functional components that all of the display, all of the UI that you get is going to be a function of the props that you pass it. So always strive to build functional components that are pure in nature that way, that don't rely on external things. And if you find yourself from within a component, it's the same with a function. Reaching out to grab something from the environment in order to show a different output, see if you can grab that thing somewhere else and just pass it as a prop. And that's going to make your component easier to test. Same with functions. If you're doing like new date, right, and grabbing the date within your function, what about if you say, no, give me the date and I'll react to that. Now you don't have that new date that is gonna bring this uncertainty to your function. Same thing with the component. Instead, now you have a component that you could test by passing different dates and you could see the results, right? It's pretty cool. Now, bring that pure thinking into your API and think about what an API is. It's a function that you call over the network. That's all it is, right? Only that when you're using functions, what do? Well, you bring in whatever the function is, and then you call the name of the function. You invoke it by calling its name. What if it's a component? Well, you import the component, and then you render it somewhere using JSX. You kind of invoke the component that way. What about an API? How do you invoke it? Through the URL and the HTTP method. That's it. It's a function that in order for you to invoke it, because at the end of the day, what is it that you're doing with routing? You're taking an HTTP method and a URL combination, and you are executing a route handler function. So it's just a function that you execute over the network. So if you think about it, if I have let's say a login method, I have a login method, and I pass the valid credentials, I should get back 200K and a token. We could check for that, right? And it is kind of a pure function. Given always, every time you give it good credentials, you should get back 200K and a token, let's say, as an example. But what happens if you give it bad credentials? Well, that's different input. Now, the input has semantic meaning. It's bad credentials. It's not that it's going to be this user or that user. It's just any bad credentials, the semantic meaning of it. I give it wrong credentials, I get back 401. And possibly some kind of message that we could check. But you get a 401 back. You could check for that, right? What if I give it the right credentials but without the right role? Well, if you pass it a user that don't have the access level required, meaning with roles, permissions, scopes, capabilities, whatever the name of that is, let's say that we use roles, without the correct level of access, you should get back a 403 with this particular message, for instance, okay? We could check for that. Now your endpoint is just a function. It's just something that is kind of almost pure, almost, right? It's always stuff happening on there. But from the point of view of the test, you could actually write tests away, thinking, I'm going to go and invoke that endpoint, pass it this kind of data. Think of the semantic meaning of the data. Is it valid credentials? Is it a valid object? Is it a valid input? And then I'm going to check that the response is like the return of the function. The response back from the server has these properties. Because giving good credentials to an endpoint that sometimes gives you 200 and sometimes gives you a 403, sometimes gives you, a 401, that's not a good endpoint. It should be predictable too. You should know what to expect when you hit that endpoint. Does that make sense? That's the lecture right there. So we can almost go home now. We just need to talk about syntax. Questions there? So we're going to approach this thinking that we're just testing a function over there. Great. That's it. Okay, let's see how to do that. So the first thing is we need this library. It's called Supertest. So we need to install it. And there are different ways for you to use it. I'm going to show you one or two. Okay. So let's go and add in here, yarn add Supertest. They did not hold back on that name. They told us we're awesome. We're like super thing, right? And then we're going to make this a dev dependency. You could go ahead and install it if you want, so that you do that the way. Okay, cool. So Supertest as a dev dependency, and now we're ready almost to use it. Here's the thing though. In web applications, if you're testing React, you have this window object, this document object, because you're running the application on the DOM. The DOM is the platform, right? So you have a lot of web APIs that are in the browser that you can use. But when you're running tests for an API that is running on a different platform, it's not running on the DOM, on the browser anymore, it's now running on Node.js, you don't have a window object anymore, or a document. You have a global object. That's the equivalent of the window object. So that means that when doing testing for Node, you need to tell Jess, hey, I'm going to be doing this, but I'm going to be running tests for Node, not for the browser anymore. So the first step that we're going to do is we're going to change that. And there are, I can mention a couple of ways of doing this. The first one is you could go into package.json. And don't worry, I'll give you time to do this. Okay. So you could go into package.json and you can add a new jest key in here. So, and this jest key, it's going to be an object, and it could have different configurations in there, including dev environment. The default value of this is JS DOM, meaning a JavaScript implementation of the DOM. So it's got everything that you find on the browser, most everything. And then if you're running in Node, there is another configuration that you can pass, and the option is Node. If we save that, when we run our test, now Jest is going to know that instead of window, we're going to have global. And all of the other stuff from the DOM, from the browser, is not going to be there. Only the Node stuff is going to be there. That's pretty cool, right? So this is one way of doing it. Now the other one, though, is there is this command that you could do. I think it's just -- init, I think. Oh, I don't have jest installed, so npx jest dash init. Okay, and this is going to ask you a few questions. The first one is, it seems you already have a jest configuration. Do you want to override it? And you can say yes or no. And it says that I have this because it detected this key already in there. If not, it will just create kind of a, it's going to create a JavaScript file in here for me. So I could say yes or no. Let's say yes. Okay, cool. Now it's telling me, would you like to create, when running Jest, would you like to configure a Jest running script, a test script on my package.json? In this case, since I already have that something and it's kind of special, I'll show you how this is special. I'm going to tell it no, but if it's a brand new project, you could tell it yes, right? It would just create that test script for you calling Jest. So I'm going to say no, leave my script alone. Now this is asking me, what do you want to run this? Do you want to run in a browser like, or you want to run this? And you see how I kind of move from one to the other. So I'm going to say no, selecting. You see that little caret there? This is telling me you're going to select node. So if I hit enter there, it's going to select node, right here. Do you want just to add coverage reports? We haven't seen that, but it's pretty nice because it's just like a little table with colors and it'll tell you how much of your code is covered by tests. So I'm going to say yes. And this is going to add a key to our configuration that's going to say something like collect coverage or something, okay? And then automatically clear mock calls and instances between every test. If you're going to be using mocking, I would say go and check the auto mock clear or something option to see what it does. But I'm going to say no for now because we're not going to deal with it. And voila, this should have created a jest.config.js file. You see it there? Let's go and kind of peruse that file for a minute to see what's in there. As you can see, our test is untouched. Okay. Remember that we had a jest key in here? Where is it? Oh, it's gone. All right. Because now we moved our configuration out of the package.json into this jest.config file. So let's go and open it. Why is this interesting? Well, because you have a whole bunch of options in here, like coverage directory. It's going to be coverage. The test environment that we had is Node. We should have something called collect coverage or something in here, somewhere in here, somewhere in here. Didn't I say yes to that? Did I say no? Ooh, let's see. And let's see. Let's see. Collect. Collect coverage. Yeah, look. I said no accidentally. So if I say true, then it will collect coverage for me. Okay. I apparently said no. Thank you. He saw that. Cool. And you remember that auto mock and all that? This is all here. So this is going to give you an idea of all of the options that you can configure for Jest. And what I would say is, I don't know what they all do. So if I knew, I would explain them to you, but I don't. But what you could do is you go and check those and say, okay, let me see what this does. And then you go and read the documentation and see what it is. Let me see what this does. Let me see what this does, right? Let me see what the globals does. So give it a try. Module directors. This is cool because this would probably be a good idea to have. Say, don't go and look for modules any deep inside my node modules. It's just gonna be always there. So just go look for modules there. I think this is the default value, so you don't need to set it up. But read about it, right? You have more configurations in there. Now, they both have pros and cons. If you need simple configuration, I would say package.json. You don't have to deal with yet another file. But I'm gonna give you a minute or two to think about why would there be value on having a separate file for the configuration? How would this be useful? Which cases? What do you think? Take a minute and type any ideas that you may have why this would be in some cases, a better option than using package.json, even though we have an extra file. And then don't type it yet. I'm going to tell you, hit enter now to see what your thought is about that. Let's take a minute. Is it okay if we go a little long on this lecture today? I just want to hang out with you a little more so that we could talk about more stuff. All right, go, 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 go. Let's see. Yeah. So that it doesn't override by other modules. So we can control configurations separate from our package.json and disable enable as needed. Better readability and separation. Absent things out. Git ignore since you don't need in production. Well, you do want to keep that configuration because everybody that downloads your code, I'm going to address that one specifically. You don't want that in the git ignore. You want that push so that when someone clones and they run the test, they have the same configuration for the test. So yeah, good idea though. Customized config, abstracting, more focus, allows it to be ignored. Yeah, again, not you don't want to do that. Changes will interfere with others. Okay, so those are all valid. Okay, even though you did not give detail, a lot of you said something about customizing and dynamically load them. So yeah, I think the opinion alert. I think the number one reason that I would use this is if I need to change the values of these things dynamically. How or why, but what is the mechanism that we could use, a simple one that we know about, in order to choose values dynamically for these keys? And the reason I can do that is because this is just a JavaScript file. I could say something like const I want include, or maybe like, well, include coverage. I mean, this is we generate it automatically, but we could write this JavaScript, right? So I could say includes coverage, right? And then make this something true or false, true, and then pass that as the value instead of collect coverage, like include coverage, right there. But now I could have this be dynamic. What can I use for this? Environment variables, that's right. So I could probably have something like process.env dot whatever, maybe node.env, is equal to this, then return true, right? Or false, right? I can say if .env is equal to, I don't know, testing, I want to include coverage, right? So I could save that now. So if I have a variable in my environment that is called not env and it says that it is testing, now my include coverage is going to be true. Otherwise, it's going to be false. So now we're dynamically based on the environment. So that means that if you run this on my computer and I don't care about that, I could just not set that and now I don't get coverage. But what's important is that these tests are going to be run automatically if you're working at a company that has a continuous integration, continuous development pipeline. The tests also run when you do a push changes to GitHub. And it's going to run all of the tests. And if a test fails, it's going to reject that push. So in that environment, you may have in your continuous development server, you don't care about the coverage, or you might. Or maybe when you're running development locally, normally what happens is the other way around. In development, you don't care, you're just writing tests. But then the CI always cares because they have a threshold. They say, we're not going to accept any changes unless it's at a 75% coverage. So maybe you care there to collect the coverage information. But there are other things here. Like maybe there are things that you care in your development environment, but you don't care about them when you're doing the CI automated on the server there, on that process. Make sense? So environment variables in combination with this, right? With conditional statements means that I could have different configurations on this dynamically, which is awesome. So pick the one you like. And if you don't need to do this, simple key for Jest and dev environment, it would suffice just to have it go. So let's leave this one in here because we probably want to see that coverage thing going on. What is that about, Luis, that you keep mentioning? I don't know if we have any tests. I don't think we do. Let me see. Yarn test. Oh, no test. Okay, cool. So we know that we have no tests. So I'm going to stop it there. And we're going to run it in a minute. Continuous integration. Yeah. CI is continuous integration, and it is a process that means that as you push code and you merge into a particular branch, some processes run in there, and that takes that code that you just merged into a particular branch, and that gets merged into the production code for release. So it's continually integrating any, like you work on a branch, and then you submit a pull request, someone approves that, and that code goes through a process of approval and gets automatically sent into the branch that will go into production for the next release. If you have continuous deployment, it's what we did. That whenever something gets to a particular branch, it gets deployed immediately. See, there's a difference. One is gonna be placed on a branch that will eventually get to production when it is deployed, manually or otherwise. That's continuous integration. It's integrated into the branch that is gonna go into production, but it doesn't go to production yet. It's not deployed. Continuous deployment goes a step further and says, yeah, I'm gonna integrate on all that, but then also, once it gets integrated to the master branch, goes to production right away. But you need to trust your system. You need to know that every piece of code that gets in there was tested, it has the right coverage. You know, everybody that needed to see it saw it, and there's a workflow for that, and everybody approved, and then it gets deployed. But most modern companies that haven't got a nice development process will have a pipeline like that to make changes, because before, what used to happen is there was a lot of red tape just to get something pushed. Even if you got it done on Monday, it may be 2 weeks later that it gets deployed to production. It's like, why did I finished this 2 weeks ago? So most modern development environments now, they have someone, it's called DevOps. It's a brand new career that we came up with that take care of that. They set all of those things, that magic, so that that process runs every time. And now you as a developer feel like some kind of instant gratification when you know that you're working really hard for a couple of weeks or months on a feature, and once you're done, you said, I'm done. I got all my tests and all that. You go and push that branch, and you do that pull request, and someone says this is good, and millions of users are using it right now, and you're like, I built that. That's my work. This is why I work 2 weeks. They're using it. It's great. It's a great feeling having something that you know that it's helping users out there making their lives easier. That's another conversation that I like to have about the ethics of what we do. We have so much impact on people's lives that I think we need to have more conversations about that, about the decisions that we make as software developers. We are affecting every aspect of people's life. If software was to stop running altogether right now, a lot of people would die. A lot of people depend on that. Even the people that don't know they do. If you use some cable box to watch TV, yeah, that's a trivial example. But a lot of people are being kept alive by cars that have computers with millions of lines of code in there. You go to the mechanic and they might tell you, oh, there's nothing I can do. You have to replace the computer on the car. They really mean it. There's a lot of software. There's a lot of code in there on your car for the brakes, for the accelerator. If one of those gets buggy and you press that brake and the software is buggy and the things that need to happen don't happen, yeah. See what I mean? So everywhere we live on software, we move the world. Cool. Now there are cool videos. Uncle Bob has a really nice video. If someone can do a quick search and find it, do a search for Uncle Bob, the future of programming, I think is the name of the talk. And he talks about this at length. There's like an hour long or something, but it's superb for you to go into the industry now without, yes, that's the one, the future of programming. Just so you know, Uncle Bob is a well-respected thinker in the industry. He's got a lot of books, but he's also a big brain that has been around for a long time. He also loves physics. So sometimes, most of the time, you can bypass like the first 10, 15 minutes of his videos, because unless you like physics too, because he explores like cool things about physics from our world. So I find them interesting. I watch them at length, like the whole thing. But you can bypass and get to the actual development stuff after 10, 12, 15 minutes. So just because fast forward that. But then he always has like those messages that will transcend any technology. So whether you work on Java, Ruby, whatever, if you change from React to something else, his messages and his teachings translate really well, and they're gonna stand the test of. They were good teachings back in the 70s, and they're still relevant. That's his specialty. He's gonna teach you things that you can apply to every technology. So I would watch his videos. They're really entertaining, but also very full, like crammed to the brim with wisdom that you can take with you to any job. Uncle Ben, Uncle Bob. Yeah, his name is Robert C. Martin. He and his son, they both write books and stuff. So I own some of them. Anyways, so back to coding. All right, back to coding. So now that we know that we can config, and the command that we run for this was just, let me type it in here. I think that's not a training kit yet. Just, so npx, just dash dash init. And that will be the configuration builder, Bob the builder. All right. And this is going to give you, you answer a couple of questions. This is going to give you the jest.config.js. Every time you make changes to that, though, you have to stop the test and restore them because those are loaded at the beginning to configure the jest environment, right? Gotcha there. Because you may make changes and like, nothing happened. Something happens, right? Now, I want to point your attention to something else in here. You see this? This is a little different from what we had before. We are using this other little package called cross environment. And the problem is that the NIC systems, like the Mac and Linux and Unix, they set environments in a different way from Windows. Just because of Windows, we need to have this extra package in there. And what this package does is this is going to find a way to set the environments automatically for you, regardless of the platform. They take care of that for you. It's a really simple package written by a Utah native here. Kenzie Dodds, I think he's the one that started that project. I think, I'm not 100% sure, but I think he's the one that started it. But then, it's an open source project, so a lot of people have committed to it. So we're doing this. What I'm saying is, I want to, for the server, I'm just running node one, no environment. It's going to use development by default. For the start, I'm just using node. Again, if you run this on Heroku, it's going to use production by default. But when I run tests, though, when I do the yarn test, for this specific case, I'm going to have a DB environment of, and we could call this to node environment if you want, a DB environment of testing. And then we have Jest with the watch and the verbose. I'm going to remove the verbose here because I want to see console logs. So we're just going to do this, okay? So testing. As a matter of fact, we could write a test for that. We could check, hey, are we running on the testing environment or not? We could check for that. Anybody care to help me write a test for that? Because that would be a good test to begin with, right? What do you think? Any volunteers? If not, we could just write it together here. But I would like to have a volunteer to help me out here. We have this API. We have the server.spec. We could definitely write it in here. Describe, it says, server. Just did, yep. Okay. The environment, testing, okay. Come on. So where would I find, if my server, if everything is working correctly, and I am reading from the environment, where would I find that information? Where would I find that value testing, this DB, that environment? Where would that be? So if I was writing an expect, where would I go find, expect, where would I go find that? In process.env. So I could say something like process.env. And then a DB that underscore env would be there, right? So I could say to be, let's see, development. Let's start there. Let's see what we can get. By default, we know it's going to be development. So let's go try it out. Say yarn test. See if that test runs. Oh, it's running. Okay, cool. Oh, look at that. So it's telling me that I expect the development of found testing. So that means environment. So if we change this to be the right test, we know that it can fail now, right? So now let's say, yeah, I want this to be always running and testing. And the reason I want to keep that test in there is I like to see that fail. If I ever run my test and I'm not setting that environment for something that we're going to do later, I want to know about it. I want to see that failing test. That, hey, you're not on testing. Okay, make sense? Good. So inside of server-spec.js, please go ahead and write this test. I'm going to drop the code in here just because this is not that. Wait, not that. This. Here we go. Let's try it out again. Boom. All right. The reason I'm not having you just type it, just copy and paste is because you know how to do this. You know how to write a spec. So yeah, 1046, I dropped the line there, npm jest -- init. What did we change? Yeah, we said that we're going to be a node. We said you can go ahead and override it. So yes, to override. The environment, change it to node. And the coverage, change it to yes. I think I may have reverted that. But then, in my case, though, I made a boo-boo because I think I have this here. Oh, I'm checking not EMB. Let's do dv.emb. See that? I had the run. I was looking for the wrong thing. I'm going to say, look at this environment instead, and then make it testing. And if it is testing, that means that this is going to be true for the coverage, and we should see coverage reports. But in order to see that, though, I need to kind of stop the test and restart him again. Please work. Please work. We are now conditionally showing that. And if you want, remember, you're going to have this file up. But understand the concept. The concept is that now I made a decision. Looking at the environment, I made a decision. I said, if I'm on testing, I want to see the reports. And the coverage right here, it's kind of really kind of weird. It's 0 everywhere because we have no code to test yet. But as we add code, you're going to see those things. And eventually it's going to tell you, hey, how much uncovered lines do you have? How much branches? And that is like branching on an if statement. How many statements you have covered by test, and there's going to be a percentage value here. Ideally, you want 100%, ideally. But some company would say, just do 80%, the 80% that matters, and leave the rest. It's fine. So this is what a coverage report is going to look like as we add code. Okay. I can also give you this. How about that? So just generate it, don't care about it, and then just replace it with this. That way we're on the same page. Yeah. I think that works. So again, we may go a little longer. Today is the last lecture just because I want to hang out a little more with you. But if you need to go though, you could just go and just watch the video later when you have time, okay? But I want it to be more informal, our last day together, like we talk about a little more things. All right, so that was our first test. We checked that we're always running on testing, and we're going to be alerted if we ever change to that. Why is that important? Well, I'm going to go and visit our old friend in the data folder, our dbconfig. It's going to look a little different from what we've seen before, because now this is reading that db environment variable again. Okay, so it's reading that, and if there's nothing in there, it's just making a development by default. This is where that is happening. But if we do have it though, it's reading from our connects file, from our next file, is reading using bracket notation, whatever key you get, either development or, in our case, testing. So if we go and visit our friend Alt Frank next file, we see that we have now two keys in there, one for development and one for testing. And they happen to be different, right? One of them is pointing to the Hobbits DB, this development right here, and the other one to the test DB. I just stopped the test and ran them again. And since we have on the file that I sent you with the configuration, we have now the collect coverage thing be true. That option will show the coverage table. This would probably make your test lower, so you probably don't want to do that until like you're done with all the tests, but just so that you know that that table exists. It's pretty cool. If you downloaded the project, downloaded the dependencies, and you run your own test, what error are you getting? It's just another, so while we get the answer to that, what the error that we're getting, the other question is, what is the difference between staging and testing? Are those just refer to environments? Normally on a workflow in a company, staging means something that is similar to production, but doesn't have any users. And the idea here is that you want to have a server that is similar with all the same versions of everything, the same database. Like if you're using Postgres in production, version 9, you want to have a staging server that looks like that and has the same versions of everything. And the thinking is, if it works on staging, there shouldn't be any problems on production. That's the thinking. Not always the case. So that's normally what staging means. It's like, this is the last step right before we send it to production, and it's got to be similar to production. Because you can have testing servers too with databases using Postgres, but maybe they're using the latest version of Postgres. This is something that is now maybe an older version of it, and they're not necessarily kept in sync with the production server. So something may work on development but not work in production, and you don't know until you deploy. So what we do is we have this intermediate step where we say, yeah, let me try it out without users first on an environment that is the same as the production server. And then once it works there, you know that it works, then you deploy to production. That's normally what staging is used for. Good question. Did you download all the packages? Because that looks exactly like the same that I have here. Oh, but you don't have jest. Did you remove jest from that command? Did you modify this somehow? All right, so it looks like you're not executing jest in there. So I'm gonna pass you this line, and in the test script, just drop that in there instead. Please let us know, Irving, if that works. Cool, perfecto. All right. So again, right, in our dbconfig.js, let me drop this Kinect file down here, so that way you have like both on screen. What this is doing is making the decision to pick the right key from there. Do I run development or do I run testing? Those are the two keys that I have in there, based on whether I have this DB environment in there. So in theory, when we run our code normally, like if I go here and do yarn server, right? In theory, this will connect. What? I have a server running in there somewhere. Oh, let me see that. Let me see if I have this here. Server that use. That's interesting. Did I have it running already? Sports server. I sync. Index.js. Bring the server. Apparently I had it running somewhere in there. Okay, because my tests, do I have a test run index? No, I don't. See if I have it running on the terminal. Sorry, it's got to be some server somewhere that is running a server. On that board, maybe. All right, let's try it again. Let's kill everything. Let's try this again. Yarn server. I could just change the port. It is running. There's something running there. Okay. How can I fix that? Simple. Let's go to the listen that's happening on index.js and change this to be 6,000. Save that. There you go. Server running on port 6,000 now. Cool. So now that we have that running, let's go visit that on the browser. Call host, not 3,000, but 6,000. And if we do that, localhost 6,000. Come on. Can we have like a get to slash on the server.js? Oh man, I'm kind of 6,000, 6,000. What is this magic? Localhost. What is this thing? What? What? Oh, come on, really? What's going on? They're just running in the middle of a class. No. Server, node one, index.js. No, I'm not showing. I'm just telling you that I don't know why my local host is not working. That's insane. I don't have anything else running there anywhere. I don't know what's going on. Truly don't know what's going on. HTTP localhost 6,000. It's like my computer just decided not to serve from that address for some reason. Okay, let's do. This is just crazy. Let's see. Okay. Server. Any broken code? Maybe that port, it doesn't like it. Let's do 8,000. It's probably the port for some reason. I don't know why it doesn't want to work on 8,000. Just gave me that weird error there, like unsafe port. There we go. Yeah, that port. Yeah, I've never run into that before. Didn't know. All right, so 8,000. We're running on 8,000. That's good. That's what we should be seeing. And if we go and look at the slash hobbits, we have some data. We have 4 hobbits in there, right? And this is because we are running the server using the development key and the development database. From the, yeah, apparently the 6,000 is something that it doesn't like. I don't know why. Now, see that test database? Look at this. This is important. Forget about 6,000 because this is important. I'm going to delete that database. This is my test database, so it doesn't exist anymore. Question is, how can I generate that test database now? I mean, if we go and look at the nextconfig.js, we have 2 environments. The one that creates that test database is the one called testing. So when we execute our command, we need to tell it, hey, I want you to run, but not on development, but on testing, okay? This is new. I think we haven't seen that. So I'm going to say npx next migrate latest, but --env is going to be testing. So this --env, we just need to pass it a value that it can find inside of next file, testing. So that means that if I had staging or production, I could run different, I could run my migrations targeting a different environment, okay? So if we do that, now it used testing to run the migration and it generated, again, a brand new test database. So you don't have to do this. I think we should take a 5-minute break so you could go around, and do the water thing. And then when we come back, let's go write a couple of tests. That should go fast, and then we continue with the rest of the lecture. What do you think? You don't have to run this. Just understand that you could pass migrations or seeds. You could pass a different environment to run off, to use. Just take 5 minutes. Let's see you in 5. Almost back. Just to heading back. All right, let's do a quick review of what's going on, because I see questions there that tells me that maybe we're not quite there yet with what's going on. Okay. How are we setting environment variables if we don't have any .env file yet? I mean, you would if you need it, but why are we not using a .env? Can someone type in there, tell me where those environment variables coming from then, if we don't have any .env file? How are we setting it? Yeah, but how are we setting that value to be testing? Who's doing that for us? I mean, we are using it, but where is it coming from? You remember the package that I said that was created by Kenzie Dodds, a Utah native here, that I think was created by him? Okay. Remember that package? What was it? Too many things at the same time, huh? Yep. Well, let's go back and kind of redo it again. I'm gonna back in time. Poof! When I open package.json, I say, yeah, this little package right here. Well, it turns out, the environments are set different depending on the operating system. The Nixes, and I mentioned Mac, Unix, and Linux, they use a syntax that is different from Windows. So because of Windows, we need to use a little package here that is going to standardize that for every operating system. So we don't have to worry about the platforms. Created by a Utah native, I think, called Kenzie Dodds. He started it. I'm back in time, like doing the same thing again. So this little package right here is the one that's setting only for the test. So if we run server or any other thing, it's just not setting anything. So only for the test, we're using this line right here to set an environment variable of db_env to testing. But it only gets set when we execute this script because it's part of the script. So if you missed that, here's where we set in that environment for the testing only. Cool? Yeah. Why not do it on a .env? Well, because sometimes you may want to run it without testing. You may want to run it targeting the development database. And those are going to be different. We have a separate test database because we want to be able to kind of wipe out the database at will. And you don't want to delete all of your development database that you'll be using for testing, every time you run the test. No, you want to keep that development database because you work with that and you'll be putting data and all that. And you want to persist that. That's going to stay there. But when you run the test, you want the ability to kind of clean the database and insert a record. Is it there? Things like that. So this is why we only do this. We only use that test database when running the tests. That's it. Special database just for the tests. Of course, if we need other variables, we are going to go and get and create a .env. And if we go and check, our index.js should probably be wired already with .env to read it if we add the .env file. So you're good to go on this server for that. Cool. That was weird that my server wouldn't run for some reason. Yeah, yarn server. Now we know that it runs fine, hopefully. So let's go do that. Cool. So we have our first test. In here. Okay. So let's go and see if we can use that library to write a few other tests for our server. What do you think? Let's try the first one. Apparently there's something with port 6000. I just haven't read what it is. I don't have the answers. Some things I just don't have the answers. Okay, so what do we learn? We learned that we could pass a flag, that's -env, to our next commands for seeding or for migrating to run it in a different environment. And that's going to look into our next file and pick that environment out of there and use that. This is how we created our database when we deleted it. Okay, so now let's go and use supertest. So supertest, if you go look at the examples on the website, they have different syntaxes. We can use Jest or we could use their syntax to write some tests. So let's go try it out. Bring it in. We call it request just because the examples call it that. It doesn't have to be called that. Supertest. Okay, now we have it. Now that it's in there, I want to test from this file. I'm going to be testing the server. So let's go bring in the server and say that this is coming from -start server.js. This is the same folder. Okay. So if I was testing an API manually, what is it that we do? You know, you open Insomnia, the client, whatever the client is, make a request, and inspect the response. Okay. The whole idea of the pure function. I open a client, whatever the client is, I make a request to the server, and then I inspect the response. Does that sound like something that you do when you're testing manually your API? Ah, okay, so something is, thanks for that, Will. So you're with me here, right? This is what we would do. We'll make a call to the API, passing any arguments if it needs it, you know, and then we're going to inspect, visually, we inspect the response. So let's check if, let's write a test for a get endpoint. That should always return 200, okay? Sounds like a plan? Actually, I'm going to write that into a describe that says, you know, this is testing get to slash. And then in here, I'm going to say it should return 200, okay. Okay. So let's see if we could do the first step. The client that we're going to use is the library request. And we need to make a get request to slash. So how do we do this? Oh, easily. We can say request, okay? And then we pass it the server. We say, this is the server that I want you to use to do this request. And the request is going to be a get to slash. And now we could do this different ways, okay? We know that this is going to return a promise. So you could do that then and do your expectation in that then. The library also have something called expect. So I could say expect 200. Okay. I think that's one way of doing it. Let's see if that passes the test, right? But I'm going to do expect 500 instead. Save that and say yarn test. And it passes, but it's lying. You see that? Let's look at our server. See that? Our API returns 200, and I'm telling it to check for 500, and it's still passing? Is everyone with me now? Or do you want me to stop for a minute so that you can finish whatever you're doing? Like if you're trying to catch up or something, I don't want you to miss this because this is kind of really important. So please tell me if you're still kind of. Here's what's going on. Turns out that the server is asynchronous. It is returning a promise. But what Jest is doing is just running the expectation and keeps on going. So it's not waiting for the response for the server to be able to check for this. So how do we do asynchronous testing with Jest? You remember that we could take on the it here, we could pass it done, call back, and then just call done, right? So one way, if we're using like the then. But the easiest by far is when you know that you have an asynchronous operation, the easiest way by far is just returning the promise. So now what I'm doing is when Jess sees that, it's gonna run this test and it's gonna get back that promise and it's gonna say, oh, it's a promise. All right, I'm gonna wait for it before running the expectations. That's what Jest is going to do. It's gonna wait for the response from the server and then it's gonna check. See that? I expected 500, but got it 200, okay. So if you ever run into false positives like that with an asynchronous operation, just return the promise and Jest will do the right thing. Such a smart library. I love it. That's one way of doing it. The other one is the example that you got from yesterday, where you could pass the done, do the that then, and then inside there, you decide when to tell Jest, yep, I'm done. Go and check the expectation now. So you have an example of that. That's the second. The other way of doing this is making this async. Okay, you make this async, and then instead of returning the promise, you capture the response of that and you run your expectations. Because it's async, you're going to use an await. So you would do something like, well, we're going to do another example with async and await, because that way it's kind of clear how when you have different ones. Okay, so this is testing the right thing now. If we go and say, no, I'm waiting for a 200, save that, and boom, should pass. There we go. But it's passing now for the right reasons. Your turn. Go write it. Let me know when you're done. This one I want you to write. Oh. I'm gonna write another test here for you. You don't need to write this one though. This is just an example. The squad is async await. Using the squad, right? I'm gonna say instead of returning, I'm gonna make this async. Okay, and then const, the response is going to be equal to await on the request to the server. It could get request to slash. It's the same thing, only that I'm capturing, now I'm awaiting for that, so I got a response here. Now I can run an expectation on the response. I can say expect rest that. And here's the cool thing. We're using this library. There's some useful information that we get on the response from the library, like the status. I could check for the status there. I could check for the body. I could check for like the code that I'm getting back, like HTTP code. I could say status is going to be to be, and if I do 500 here, the second test should fail. The first one passes, but the second should fail. See, it's failing, and it's failing for the right reason. If I change this to be 200, which is what we expect, both tests should pass. This one is using the expect from the library. This one is using the expect from Jest. Making it async, we await, grab the response, and the response has some useful stuff like, let's write another one. Let's check for the content type to be JSON, right? That's another test that you might want to do. If you're building JSON APIs, you want to make sure that the content that you get is actually JSON. So we could do that. We could say, instead of status, I could say the type. The reason I'm doing this, if you don't do it this way, you need to know that the header is called content type. And you could check using expect, you could check content type equal application JSON, right? But in this case, you don't even need to know what the header is type. You could just say, hey, give me the type, and I want this thing to be. And when you do the to be, you could use a regular expression there too. Or you could just say, if you know exactly what it is, application JSON. I'm gonna change this to make it fail. Say XML. I'm gonna say I want this to be application XML, which is another format for transferring data over the network. And it's gonna tell me, you wanted XML, but I gave you back JSON. The server gave me back JSON. So now we fix it because now we know that we're looking at the response type correctly. We saw it fail. Here we go. So now using async and wait or using promises, let me show you the other way so you can have an example of all three, right? Done. Instead of using a wait now, we're just gonna make that call. Get, and then we only care about the then, not the catch. We're just checking for the then. We're gonna do the response in here. And now we can run our expectation to be that, but then we need to tell Jess, hey, it's time now for you to go and run it. So we just say done here. Okay, using done callback. Should return JSON. Okay. Now in this file, you have three ways: using async and wait, using then with the done callback, or even using just the expect from the library. And here's the key. Okay. So in this one, we return the promise. In this one, we use the squad. And then on this one, using the done callback. Three ways of handling asynchronous code. All right, dropping this for you on Slack. I don't want you to waste a lot of time just trying to write this because it's just simple, right? I want to see questions though. Why are we doing this? Why do we need to do that? Make sure that you have the async right before the callback on the it, not on the describe. And also that you're using awaiting here, right? You need that await. Which is the most effective? I would say if you expect that you're gonna have a response that is gonna be really, really slow, I would probably go with the done. But I think they're all the same, actually. I think they work the same. I don't know what the answer to that is, really. I don't know if there are differences internally. Even though I don't know what the answer is, the correct answer, I would say use the one that you can read better. That makes the most sense to you. Use that until there is a compelling reason that you find out that I don't know about to change to a different syntax. That's my recommendation. The one that you can read and understand better. Use that first. I wish I had all the answers, but I don't. So we'll drop this file and so you could come up with those because I'm sure it's just some kind of syntax somewhere in there. Some typo, maybe. Space between. Oh man, that was funny. So his problem is that we had a spacing here. It's like equals greater than. Yeah. Cool. Typos. Yeah. Brandy, what would you say to that? Brandy was like, typos are going to be the death of me as a developer. So why does return? That's a good question. Why does return the promise works? Because jest will inspect what you get back out of that test and says, is this a promise? And if it is, I'm going to wait. So this is the Facebook people doing that magic in there. They just check and say, is this a promise? Yes. Good. I'm going to wait. Good. Facebook engineers, man, they just don't know their stuff. All right, so you have learned handling asynchronous operations, 3 different methods. You have checked the status code in an easy way, in a different way, and check for JSON. What if I want to check, for instance, this server should return something like API up or something like that? Can I check the shape of an object? Make sure that I'm getting the right response. So let's say that I write a testing here that says should return, you know, API up. Okay. I really like to have a volunteer helping me out with this test. Josh, I'm gonna give you 5 seconds to volunteer. If not, Josh is gonna give us a tribute. So 5, 4, 3, 2, 1. Okay, Will. All right, Josh, can you make sure that Will is unmuted, please? Thank you very much. I just have all my Zoom stuff hidden.
Hi.
It's like, I'm gonna wait for that. I want the suspense, like the grand entrance, last second, right there. All right, so let's see if we can figure out a way to check the body of the response that we got. So walk me through this, man. Let's go.
Okay. Um, so I guess the first thing to do would be um, to deconstruct the. Uh, well, no, that wouldn't be first. You want to make the request first, right?
Of course. So this is a request, and yeah, I'm gonna leave it there. Request to the server, right? This is our server.
Yeah,
And
request the
you know what?
server.
Just so you know, people like what the library is doing is spinning up an instance of the server in memory when it runs that test. That's like a separate server that it runs just for this test. It's pretty cool. So, and then we're gonna do a get, I guess, right? Because we're testing this get slash.
Yeah.
What else?
Get, and then so we're not going to do an async. Okay. We'll do it then off of that.
No, I could do whatever you want. You want to do async?
No. Let's just stick with the a dot then off of that.
All right.
And then we're going to get a response, and then we could just const, and then you're going to deconstruct. Oh, I'm sorry.
No, yeah, you were saying?
You're missing an S there, but const deconstruct, like open and close the curly braces, and then see res dot, or I'm sorry, no, not res. I'm sorry. Body.
Is that what you want to do? I grab the body out of the response?
Yeah.
Okay.
And then I guess we'd have a body dot API out of that, right?
Yeah, we could do that.
I should have done the other way around, but yeah, it works. Hopefully.
So how
Let's
do we
see.
check?
Expect body dot API to be up. Let's see
Cool.
if that works, I guess.
Yeah, let's make sure that we test that it can break. So
Oh yeah.
down. And it passes. What's going on there?
That's weird. It says expected down and received. Oh, to equal.
Okay.
Maybe instead of to be.
To equal. It's just testing a string, though. Primitive values should work fine with to be.
That is weird though. Why is that? Because it says
Oh,
right
look at
there
that.
in difference
Look at that. Look at that.
received up was expecting down.
Huh? It kind of worked. I don't know. I don't even know why that worked, though. Let's see. Let's try it again. Yarn test.
But it still passed.
No, it failed.
Oh, it did?
Well, it didn't really fail. What we got was a rejection, right? But we still have this passing up there. Why is it that it's passing? It shouldn't pass.
Yeah, I don't know.
Okay. So here's what happened, right? The test passed, but then it failed. So it threw, and then you get the message for the failure down here. So it's like, why did it not kind of wait for the response before checking?
um,
So eventually, when the problem is resolved, it saw that it fails, but first it told you that it passed.
oh, I didn't do a return for the request.
Yeah. So it's not waiting. So now if we do this and we save that, it's gonna wait before telling me and making its decision. Now it fails.
Aha.
So we could also do to be because this is just a primitive string, so it should work too. And fail that way with to be. There you go. Still have the same
Hopefully
thing.
it passes if you pass it up. Now you got me like
Okay.
suspense. Okay.
Right. So every time you see weird behavior like that, like it passes, but then a little later it fails, this is when the actual response came back and it was like, ah, I made a mistake. I should have told you it failed. So, yep, that's gonna get you a lot. Okay.
Cool.
Return to the promise. Good job. Of course, you could probably do the rest dot body, that APA to be up. That's one thing that you could do. And if you want to check that this is exactly the thing that's there, like the whole thing, you could say something like, again, this is good, right? I'm not saying it's not. A different approach, like expected equals this. Not that, but only what the, there you go. Expected, it's going to be API up. And then once we have that, we could probably say res.body, right, to equal expected, right? We could do that.
But what if you're expecting more things to be
Exactly.
in there?
So
Then you
this would work if we expect that the body is going to have only this. It's going to be exactly that. If not, if you just want to check for the API value, then your solution is the correct one. And then you don't care whatever is there, just making sure that API says up.
is there a to include? Because like I'm just thinking of if there's something instead of to equal, uh, to include, to have that as a key
As
value.
a, as a matcher, right?
Yeah.
I'm sure someone wrote it in there, but if not, you can kind of fake it using object keys. Like you could check the keys on the object and see if that key is there. With the
Okay.
object keys, you also have these for off. You go through the keys of an object and checking to see if you have it there. Like you could probably fake it, but I'm sure there is a matcher. If not on the Jest library, someone else probably wrote a matcher somewhere in there that you can extend it.
But that's a pretty specific situation, though.
Yeah, I don't know one off the top of my head, but you could definitely check it for yourself. Like check with the object key. Cool.
Cool.
All right. Thank you, Will. Good job. It worked, right? And we troubleshoot the error that we had there. So those are three simple tests that you could do. You could drill into the body of the response and check for a specific key. If you want to check the whole thing, you could check for a key to make sure the value is right. You can also check for the status code that you get. You can also check for the type that you got. Do those three checks for every endpoint and you got like the beginning of your testing suite. The rest, like logic for validation, all of those are going to be functions, pure functions. So you're probably going to abstract it away in some kind of file, just import that and test it like we tested on day one. They're just functions that you could pass in an object and see what you get back. Make them pure subfunctions. It's going to be better for it, right? So that you don't have to do validation in place here on the endpoint or on the models. Cool. One thing that you may have not noticed there is he just gave us a lesson on whiteboarding. He didn't set out to do that, but he did. One of the things that you want to do when you do whiteboarding, there are a few things that you want to take into account, but one of them is you want to talk as you think into the problem. And it is okay if you don't have the solution yet. You say, okay, yeah, maybe I could do this. No, not really. See, the interviewer is going to love it when you do that because they're going to see your thinking. If you just stand there with a thing in hand where they're yawning and you're like 3 minutes thinking about this in your head, that's not going to go well. Talk to your thinking as you're doing the exercise. Believe it or not, hearing yourself say something may trigger something else. It happens to me. Okay? It may happen to you. Isn't that a movie? Someone wins the lottery. It may happen to you. It could happen to you. Cool. Now, what else is important? Probably not a lot of people think about this, but buy instead of this, I want you to buy this when you go to interviews. This is not about, oh, it's over here. This is not about the brand. It's about the thickness. So when you're doing a whiteboarding exercise, you want to leave space between the lines that you write on the whiteboard, enough space. And you may end up doing it on a really small whiteboard or on a whiteboard that has more stuff. So one thing that I do is I think if I need to go into an interview, I buy, you take yourself your own markers. You take, 4 or 5 markers if you want to do a couple of colors. Make sure that they are good before you go. Because there's nothing worse than you being there in the middle of have an idea and then your marker stops working. You kind of lose the idea because you have to go and get another marker. So take your own markers and make it thin like that. The reason they're thin is that so you can fit more code in the screen. So you have, and then you leave white space between it. So when you go onto the whiteboard, break it out in 2, and then you begin on the left side. So if you don't have enough space by the time you get to the bottom, you still have half the thing. Don't type across the whole thing and then you're like, I don't know where to fit it, right? So that's gonna show that you plan this out. So, and if you have a small like this, and it's a big, one of those 6 feet, whatever, big ones, you could probably divide it in 3 or 4 because you're using a smaller point. Don't start writing on the wall. That's not gonna go well either, okay, unless the wall is for that. So enough space, because sometimes you write something and you're like, I have to go back and now insert something. It's easy to do it in code, but not on the whiteboard. So plan on that, on maybe you need some extra space. So space them out, and then go back and add the new lines in there. That's it, whiteboarding lesson done. So what haven't we tested of this? Well, we haven't used a database. And the database, and I'm okay with you asking questions and watch me do it and just keeping the code because there's no super magical code in here. We have this insert function. I'm going to test that one out, and then you could probably go from there. And the idea here, if I want to test this, I want to kind of go check the database, make sure that I don't have any data in there, insert a record, and then check that that record is in there. That's what we want to do. If you were doing it manually, you would run the code, insert a record, and then go and check if the record is in the database, right? That's probably how you would do it. So we're going to do the same thing. So we have this. This is not implemented yet. So we need to implement it too. And also we have this spec modeling here, model aspects, and this is what's gonna house our tests. So let's go and test that first. We need to import it, of course. So bring it, not that. Bring in our model. We're gonna call it hobbits. I don't know. I like to call the model hobbits with uppercase, telling me, yeah, this is the model because it's uppercase, Luis. This is the model. But not everybody is going to understand what's going on, so you have to make sure that your team understand the way that you're doing this. So it's model.js. Hobbits model.js. Yeah, that's good. So now we have the model. I'm going to say, okay, this is test for the Hobbits model. Let's insert the insert method. That's the one that we're going to be testing. And then we're going to come in here. Modelo time. Outside the box thinking, start writing in the wall. That would be nice. Like, why are you doing this? Like, I'm thinking outside the box. Pretty nice. So let's see, what would that look like if I wanted to test kind of that we're doing an insert? Okay, so let's do something like should insert provided. I know it's a Hobbit, so I'm going to call it Hobbit. Provided Hobbit. So again, preference, I'm going to do async and await just because it reads fine, right? So I'm going to say const db. Okay, I need access to the DB. The reason I want to have access to the DB, and the DB is just a configuration file, is because remember, what do? We use the API to insert, but I don't want to trust the API. I want to verify myself. So I'm going to use the API to insert, and then I'm going to use a direct access to next to go and look at the database. It's there, right? So I'm going to use that. So we're going to require dot I think it's in data our dbconfig.js, right? We're going to grab that because that's going to be configured correctly. Since we're doing testing, it's going to be looking at the testing database. Cool. Stop me if this is not making sense. And then I want to grab the hobbits, right? The hobbits would be this model. If I want to have it like inside the test only, or I could just use it from up there. I'm okay using it for up there because all of this file is going to be about the hobbits model. So I'm going to keep the hobbits model up there. If it makes you feel uncomfortable, you can just require it inside the test so that every test has everything it needs. Okay. Now, again, the same thing with the database. We could have it this down here, or we could have it up here. I feel okay in both cases having it up there. Like having it up there, be global for the whole file, because it's only about the model and it's only about testing the database access. Okay? Show you both ways. Now, what is it that I want to do? Well, I want to insert a hobbit. So I wait on the hobbits.insert, and I'm going to pass it a hobbit that should have at least a name of Gaffer. Who's Gaffer? Anybody knows? So now we did the insert. And now I'm going to say const hobbits, all of the hobbits, it's going to be equal to await on the, I have this DB up there, and I could say, give me the hobbits table. And then we could run some sections like expect that, you know, the hobbits, that should be an array that we get back with all the hobbits. And it's an array, I could say something like to have length 1. Okay, so I wanted to have only a single record in there. Let's make sure that this can fail. I'm going to say to have length 2 or 0. Let's do 0, length 0. It's going to fail miserably, of course. All right. By the way, this is kind of getting annoying now. I'm gonna leave it there. It's fine. Okay. So it says that it's passing, right? And the reason it's passing, even though we kind of called insert here, but still this is passing. This is passing because we're checking for 0. If we haven't now checked for the right thing, which is it there? Did it insert correctly? And what this is testing is my wire for the Hobbit models connecting correctly to the database? Is it working correctly with the database? And no, it's not. We have a failing test. It's true because it's just returning null. So yeah, we should go and fix it. So let's go write a little bit of code here. Anybody wants to volunteer? I have 3 seconds to volunteer for this one. 2, 2.5, 2.75, 2.90, 3. Okay, I give up. So let's go and implement this. How would that look like if you were doing this? Oh, it's an async function. Oh, so we could just probably just, if it's an async function, I could just say something like const. I'm going to get the IDs back by just await db hobbits and then calling insert, is it? And passing the hobbit. Okay. All right, that works. So now we have the insert, but that will return only the IDs. And I'm thinking that I may later want to know whether I got the right insert, the right thing inserted. So I want to return, I'm going to have this endpoint return the hobbit instead. So we have the IDs, right? So I could say, what can I do here to go and get it? Because I return from my DB hobbits where the ID is equal to IDs dot, and remember that the IDs is just a collection that has the last ID that we inserted. So it would be like IDs bracket 0, right? Make sense? Because this is going to be an array. It's going to be like this, like that. So we're grabbing that element there. The other thing that we could do is, tell me if this is weird, I could destructure that and say the first element of that array that I get back is going to be the ID, and now this is going to be a lot simpler. Did I lose you there? Hobbits. Thank you, chat. All right, so this is going to return an array. I could just call first on it. Say, send me back the first record. So here's what this is going to do. It's going to insert, get back that array of IDs with one single ID. I'm going to destructure that first element out of there as ID, and then I'm going to do a where and grab the first record that I get. This is going to either return me nothing, null, or it's going to return me the hobbit that I just inserted, right? Because I just inserted it and I got the ID. Ooh. Oh, fancy. We have colors. Let's see. Haha, look at that statement. 50% of the statement, 100% of the branch, because it's a single branch. And then 50% of the line, 20% of the functions. On cover lines, 20, 24, 28, and 32 on this file. This one is not covered by a test. This one is not covered by a test. This one is not, and this one is not covered by a test, right? So you see how now I'm collecting information about the stuff that I haven't tested. Like it? Okay. All right, so we checked for that, but I would like to check a little more. I'd like to know, is it the gaffer though? What if there was something left over on the database? What if I do this? Stop the test, run the test again. Would it always be, can I trust it that, when I run that test, can I trust it that it's actually the gaffer that I got? Oh, look at that. Look, I stopped the tests. And now suddenly it's failing. Okay, I don't know what to do now. Why is it failing? Can you spot the problem? Yeah, the reason for that is I ran the test once and inserted a record, and then I ran it again and it inserted a record again. That's not what we want. And this is why it's important to have a separate test database. I would love to clean it up. I want to make sure that every time I run the test, my database is totally clean before it checks for anything, okay? Or after. You could do after or before. Either way works. Turns out that Our friends on Jest have a few methods that we can use to run code before all of the tests, before each test, after each test, or after all of the tests. A good candidate for this would be, and you could have it out here, right? This is going to respect the JavaScript scope. I could have it out here. It's going to apply to all of the tests in this file. Or I could have it inside, say, I only want this to apply to the Hobbits model tests. Okay, so pick your poison. I'm going to do it in here. I'm going to say before all. The other ones are before each, and then you have after of both, right? So I'm going to say before all of the tests. And then I pass a function in here, okay? And this function is going to deal with the database, so I'm going to make it async. This is something that is not immediately obvious when you're doing this the first time. I know it got me, right? So we're going to make this async so that I can do an await on this. And I'm going to say await db hobbits. And what is that command? Props, if you remember the command that will empty out a table and reset the IDs. Truncate. Wow, what a memory. Incredible. Yep. So now I could do this, if we do the right arrow there. I could say, hey, before any of the tests, I want you just to first go into the hobbits and truncate the table, because I'm dealing with the hobbits table here, right? Save that. And since this is async, you could run as many operations you want on the database there. It passed, but it passed the first time. Now the question, if I stop the test like I did before, don't cheat, Luis, don't cheat, do it again. Stop the test and I run it again. It's still passing though. And it is, right? So what we have learned is that there is this before all, before each, before, after each, and after all, that we can write some code inside this function that's going to get executed before, in this case, before all of my tests. Okay. Now, this may work because I have a single test in there. But if I went ahead and wrote another test that is kind of testing similar things, right? Because remember that before all, this is also something that is not immediately obvious. The before all runs once, and then you run all the tests. So what if I have another one that I'm inserting the gaffer, or maybe another one? So instead, I'm going to say something like let hobbit be equal to, await this, insert gaffer. And then I'm going to run an expectation in here that says expect the hobbit. And remember, this hobbit is the hobbit that we get back from our API, right? So I'm going to say expect that the hobbit that name to be gaffer, okay? And then we do this, and then we do something similar. Copy this and say, let me leave that one there because I think that could be useful as part of this exercise. Then I say, actually, I'm going to add also Sam, father and son, right? I'm going to check Sam. And I'm grabbing the hobbit again. This is why I made it a let. So I could say, all right, insert that, and the hobbit that I get is Gaffer. Then I insert it again, another one, and the name that I got is Sam now. So I'm checking that when my insert functionality works, it's returning the inserted hobbit back from the database, right? Remember that you get this hobbit from the database. So it's going round trip to the database. You're testing both things, that the insert works and the data that you return back is from the database. Pretty cool. So let's save that. And then, of course, I check that I shouldn't have one. I should have two. But I have three. What? Right? So props if you could tell me, because I just inserted only two. So I should be able to say, I'm going to insert two. And now I have five. It's crazy. It's like growing and growing and growing. Look. Oh, well, I have only three. That's fine. Because I only set it one here and two here. Three. So what can I do? Because this isn't really working the way that I yeah, right? We want to clean it up before each test, because that's the problem. I clean it up, it's fine, inserted one, then two more, so I have three, always have three. Because every time they run, they cleans up, but then you run to test. So instead of before all, I'm gonna do before each. Right? Now it's gonna run, clean up, have one, run, insert two, clean up, and have two. Everything passes. Questions there? So what have we done today? And here's important, right? If you go and check the database is empty, before each test is emptied, it's gonna have some data left over in there. You can make this also a before and after. After each, if you wanna do that instead, you say after each. And now you guarantee that at the time, by the time you run all of the tests, your database is clean, right? The thing is that you're gonna get that the first time you run it. So you're gonna have to kind of run it again just to clean it up, because now they're clean, but since it was now an after each instead of before each, you need to run it again. But then after that, it's always gonna work, right? It's just that little thing, the way that it works. Now it's good, and I don't know, the test is still gonna be good. So if we say, I'm gonna run this and say Frodo, it's gonna fail, but at least I ran the test again, and you'll see that it's gonna fail for that, but then I could change it back to be Sam. So if you have this in place from the beginning, before you start writing your test, this is always gonna work fine. After each or before each, they all work. After each is gonna leave the database empty, before each is gonna clean it out before it runs, no matter what was there. Cool. So we have learned about asynchronous tests, the different ways of writing it. We have learned about super tests. We have learned how to check the body and all that. We have seen examples. Doesn't mean that we learned it. We have seen examples that say that. You won't remember all of this, right? We have seen examples of using a test database by reading for the environment and picking the right configuration file. That's powerful. It's really powerful. And now we could just clean out that table because you're using SQLite, and we set it up specifically for this connection to not deal with foreign keys. You can always call truncate on a table, no matter what. So you could just call truncate, clean it up, and now you're testing your database. You could do this with a put, with a delete. You could say, I'm going to insert a record. I'm going to check that it's there, right? The way that we're doing it here. And then I'm going to call delete. And then I'm going to check that it's not there anymore. I'm going to insert two records, check that they're there. And then I'm going to delete one and check that the length is only one left. So you could write tests with this same approach. This is the end of our lecture. Do you have any questions? Is it good practice to use both before and after each at the same time? If you need them, just think, what is it that you need? How do you want to approach it? Most of the time you don't need both, but in some cases though, you might want to have some code that runs at the beginning, but then you want to have some other code that runs at the end. So I'm not going to say that is a good practice, but it is okay. If you need that, you could have all four if you need all four, for sure. You could have, let's say, let me tell you, there is a way to create, in the schema builder, you can create a whole database. And you can use Kinect raw to write SQL to create a database manually if you want to do that. So you could have a before all that says, I'm going to create a database for this test. And then in the after all, say drop the database. So the database is not even there until you run the test. So it's going to run the test, create the database at the table. And then at the end said, drop the database, including the table. Most of the times, I don't like to do that because it's extra time. You just have the test database in place already. That's going to save you a lot of time instead of having to drop and create. But if what you're testing is code that dynamically creates a table, yeah, you can have code that creates that table and test it. All right, so this is the end of the lecture again, right? So I'm going to ask Josh to stop this recording so that we separate this for the next recording.